Hello Year 12, and in this video we're going to solve some trigonometric equations, and they're very similar to the equations that you did in Year 12, apart from this time we're going to insist that your answers are given in radians. So let's start with the equation cos theta equals 0.2. We want to give our answer in radians. Well, we can see that 0.2 is approximately here, and we're asked for solutions between minus 2 pi and 2 pi. So we can see that we are looking for 4 solutions, which are here, 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 and here. And we need to be a bit careful now because we need these solutions in radians. So firstly, I'm going to start labelling my cosine graph. So I've got my key points on there. So we know 2 pi is here. We know 3 over 2 pi is here. We know that pi over 2 is here. We know that pi is here. And we know 0 is here. And we can do a similar thing here. Minus pi over 2, minus pi, minus 3 pi over 2, minus 2 pi. And what you would do in Year 12, you would have said cosine inverse of 0.2. But you'd have been really sure to make sure your calculator is in degrees mode. And what we need to do here is we need to make sure our calculator is in radians mode. So to do that, you're going to press Shift and then Menu and then Angle Unit by pressing 2 and then Radian. And that will make sure your calculator is in radians mode. So now you get that this is 1.369 to 3 decimal places radians, and that is one of our solutions. And in particular, that is this solution here, which is approximately 1.34. We need to look for those other 2 solutions, other 3 solutions. So we can see we have one here, which is a distance of 1.34 radians from 2 pi. So we have another solution, which is 2 pi subtract 1.34. And then because of the symmetry of the cosine graph, we can just take the negative of this and also the negative of 1.369. So our values of theta here are going to be plus or minus 1.369 and plus or minus 2 pi subtract 1.369, well, that is 2 times pi subtract 1.369, which gives us plus or minus 4.914 to 3 decimal places. And that is the value of our 4 values of theta, which are here. Sorry, not there. Here, 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 and here. Okay, example 2. Well, in example 2, we need to do a bit of algebra first. So we've got 4 sine squared x equals 3. So dividing both sides by 4, we have sine squared x equals 3 over 4. And then taking a square root, but we're being very careful to ensure we have a plus or minus. We get the square root plus or minus the square root of 2. So we're looking for between minus pi over 2, minus 2 pi and 2 pi, when is sine x equal to root 3 over 2 and negative root 3 over 2. So we can see if this is root 3 over 2, we have a solution here and a solution here and here. Minus root 3 over 2, we have a solution here and we have a solution here. And if we just put in our important values, so we know that this is 2 pi, we know this is pi, we know this is 0, we know this is minus pi, we know this is negative 2 pi. You can perhaps see through the symmetry of sine, whatever value this value here is, this is just going to be the negative bit. And whatever value this is just going to be the negative bit. So the first one is going to be the principal value of x. So we're going to have sine inverse of root 3 over 2. You perhaps should know this one is 60 degrees. So you should perhaps know that this one is pi over 3 radians, and that is our first solution. Well, this one here, this is okay because this is just pi over 3 from pi here. So this is just going to be so we have x equals pi over 3, but we have this one here which is going to be pi subtract pi over 3, which is 2 pi over 3, and then we can just take the negatives and positives of those. So we get x is plus or minus pi over 3, and x is plus or minus 2 pi over 3. So 2 pi over 3, negative pi over 3, negative 2 pi over 3.